Hi students, in this lecture I am going to discuss problems based on spherical mirrors. Let us see first one. Let's see the question given. A concave mirror of focal length 20 centimeter is moving with a velocity 2 meter per second along its principal axis. At the instant shown in the figure, so we have to find velocity of image with respect to mirror, with respect to ground. Okay, let us see how to solve it. Right, first note down the given data. Given concave mirror, so it is a concave mirror, focal length given 20 centimeter and given coordinates, this is x and y, and mirror is moving with a velocity, it is 2 meter per second, and velocity of object making angle 53, and its speed is 15 meter per second, and its separation is given at one instant, that is at 30 centimeter. Now at this instant, we have to find the velocity of image with respect to mirror. Velocity of image with respect to mirror. Next, velocity of image with respect to ground. This is now given data. Let us see how to start it. So we have discussed that velocity of image with respect to mirror along x-axis means along principal axis, that is equal to minus f upon f minus u whole square into velocity of object with respect to mirror along x-axis. It is suffix x. Right. Let us see the value of velocity of object with respect to mirror along x-axis. So this is now 15 cos 53. Velocity of object along x-axis in ground frame. It is a 15 cos 53. So 15 cos 53, 3 by 5. This is 3 times. So 9 meter per second. That is velocity of object along x-axis in ground frame. And coming to mirror, its velocity 2 meter per second along negative x-axis. Therefore, velocity of object with respect to mirror along x-axis, that is now 9 plus 2, it is 11 meter per second. It is along positive x-axis. Okay. Next, coming to velocity of object with respect to mirror along y-axis. For mirror, there is no velocity along y-axis. And coming to object, 15 sine 53. See how much? 15 sine 53, 4 by 5, 3 times 3 fourths 12. It is 12 meter per second. This is velocity of object with respect to mirror, or you can say with respect to ground. Both are same. Okay. Along y-axis 12. Let us now focus its velocity. Right. So now coming to here, velocity of image with respect to mirror along x-axis. That is given by velocity of image with respect to mirror along x-axis is given by minus. See what is F? It is given 20. This is a concave mirror. According to sun convention, its a coordinate means coordinate of focus is minus 20. So minus 20. Next, F value minus 20 minus U value. U is now minus 30. So minus of minus. Alright, minus 30 only here. Minus 30 whole square. Next, velocity of object with respect to mirror along x-axis. That is how much? 11. So take here 11. Now see carefully. Minus of minus plus. So 30 minus 20. That is a 10. So it is now minus 20 by 10. Minus 2. Minus 2 whole square. That is a 4. 4 11. So 44. Having here minus outside. So minus 44. So it indicates this negative sign. This is now along negative x-axis, right? Now we have to focus what is velocity of image with respect to mirror along y-axis. Okay, so this we have to focus. See how to get it. Remember, this is a point object. Point object means it has no size. Okay, in such a case, if you want to find y component of velocity, so we are taking that as rate of change of y coordinate with respect to time. So I'm writing here magnification equal to writing y coordinate, okay, instead of height, because it is a point object. That's why instead of taking height of image by height of object, I'm taking y coordinate of image by that of object, which is equal to minus v by u, right? Now see from this, y coordinate of image is equal to minus v upon u into y naught. Now we have to focus rate of change of y coordinate of image. Derivative of y coordinate of image with respect to time. That is now velocity of image with respect to mirror along y-axis. That is equal to, I am taking here minus outside, d by dt of v by u into y naught. And you can see here y naught, u, v. These are now variables, all three, right? Then see what we get here. This is equal to, I am taking minus outside. So now we have to take a derivative for all these three variables. So in that we are taking, let us take first these two are constants, then derivative of y naught. V by u, taking these two constants, derivative of y naught. That is dy naught by dt. Okay. Next, let us take here bracket like this. Next, see what we can do. Let us take v constant and y not a constant derivative of y. Okay. But in this problem, y naught is 0. Therefore, that derivative becomes 0. That term becomes 0. Next, let us take u is a constant and y naught a constant derivative of v. Again, in this, y naught is 0. That means the third term also 0. See carefully what I am doing here. First, we have taken v and u constants derivative of y naught. Right. Next, let us take v constant, y naught a constant derivative of u. Now in this, y naught is 0 because it is on x-axis. Therefore, that term becomes 0. Next, take u constant, y naught a constant derivative of v. And again in this, y naught is 0. So that also becomes 0. So finally see what we got here. It is velocity of image with respect to mirror along y-axis is equal to minus v by u. That is nothing but magnification, right? That is nothing but magnification. Yeah. Next, dy naught by dt. This is nothing but y component of velocity of object. And that is how much we're having here. It is 12, right? Right. Then see what we get here. Coming to here, do one thing, substitute values in this. Substitute values here. Dy by dt. We are having minus already outside. V by u, dy naught by dt. Right. Minus in the place of v by u. In the place of v by u, see what we can write. Or directly minus v by u. There we are writing magnification rate, that is f by f minus u. Okay. So I am writing here in the place of minus v by u. In the place of that magnification, f by f minus u into dy naught by dt. That value, how much we got? 12. So into 12. Now see what we get here. It is f value how much? It is minus 20, minus 20, minus 20, minus u value. It is how much we got u value? Minus 30, minus 30 into 12. Then see what we get here. This is now minus 20 plus 30. This is a plus 10. Plus 10 and this is minus 20. Minus 20 by plus 10. This is minus 2. That means it is now minus 24. Okay. Minus indicates that this is now along negative y-axis. Okay. This minus indicates it is along negative y-axis. Now we have to calculate velocity of image with respect to mirror. So now we can see directly answer for that. Velocity of image with respect to mirror is equal to, it's a component along x-axis, that is minus 44. So minus 44 I cap. Okay. Next, it's a component along y-axis, that is minus 24. Right. So this is minus 24 j cap. This is velocity of image with respect to mirror, right? See, and you can see we have to find velocity of image with respect to ground, right? Then see what I am doing here. After having this is equal to velocity of image with respect to ground, right? Wait, we have to find velocity of image with respect to ground. Then this is velocity of image minus velocity of mirror. So velocity of image in ground frame minus velocity of mirror. Okay. See from that what we can get. So I'm writing here. Velocity of image in ground frame is equal to. So this is now velocity of mirror. That value how much? It is 2. 2 along negative x-axis. Okay. Along negative x-axis. So when I'm taking this one to here plus Vm, right? I'm writing here velocity of image with respect to mirror plus velocity of mirror. Okay, right. Now velocity of image with respect to mirror is now minus 44 I cap minus 24 j cap. This is now minus 2 I cap along negative x-axis. So minus 2 I cap. So it becomes now minus 44 I cap, no change in that x component. Coming to y component, it becomes now 26 j cap. See carefully, it becomes now, wait, sorry. It is along x-axis, right? Along x-axis. Sorry, because mirror is having velocity along x-axis. So we have to add to x-axis. It becomes now 44 plus 2, 46. 46 I cap and 24 as usual, 24 j cap. This is now with respect to ground. Okay. So like this, we can calculate y component of velocity of image. Students, you have to focus carefully this step. Okay. The remaining two terms, they have become zero, right? Suppose if y is not on y-axis, it is above this one. Okay. If it is above this one, then in that case, these two are not zero. Is that point clear?